In this video, we'll be looking at how to derive the sum and difference of angles trigonometric identities from the very basic sum trigonometric identity. Sine of alpha plus beta is equal to sine of alpha times cosine of beta plus sine of beta times cosine of alpha. We'll be looking at how to derive the sine of alpha minus beta, the cosine of alpha plus beta, and the cosine of alpha minus beta from this equation. We're going to begin by using the trigonometric identity we do know, sine of alpha plus beta, to find sine of alpha minus beta. And we can do this by simply saying that sine of alpha minus beta is the same thing as saying sine of alpha plus negative beta. And now that we have this, we can simply use our previous trigonometric identity that we already have for sine of alpha plus beta to find sine of alpha minus beta. So let's go ahead and do that. So let's say sine of alpha plus negative beta is equal to the sine of alpha times the cosine of negative beta plus the sine of negative beta times the cosine of alpha. And remember that in our derived equation up here, in our given equation up here, sorry, that beta and alpha are simply placeholders. You can really replace those with any variables you want, which is why we can replace the beta with the negative beta. Now, evaluating for this, we're going to have to use some other trigonometric identities, which you should already know. So sine of alpha simply stays as sine is alpha. Now, cosine of negative beta, if we use our trigonometric identities, we know that cosine of negative beta is simply equal to cosine of beta, so that doesn't change. Cosine of beta. Sine, on the other hand, if we are looking for the trigonometric identity of sine of negative beta, that turns into negative sine of beta. And you should also be able to figure that out using a unit circle, so that we do the negative sine of beta. I'm just going to turn the sign up front into a negative, and then cosine of alpha does not change. And now we have a identity for the sine of alpha minus beta. Now that we have our identity for sine of alpha minus beta, I'm simply going to write it up top with the other identity and make space for the other two identities we still have to derive. So sine of alpha minus beta is equal to sine of alpha cosine beta minus the sine of beta cosine alpha. Okay, so I've gone ahead and erased the rest of it, so now we have room for everything else. And now we're going to move on to our next identity, cosine of alpha plus beta. Now how we're going to derive this is by using another trigonometric identity outside of these, which is that the sine or the cosine of theta is equal to the sine of 90 minus theta. This also works vice versa, where sine of theta is equal to the cosine of 90 minus theta. But we're going to be more focused on the top one up here, because we're going to use that to solve for cosine of alpha plus beta. Let's take cosine of alpha plus beta. Cosine of alpha plus beta, what is that in terms of sine? Well, using our nice little two identities we have up here for much simpler identities, or we can take the sine equivalent of cosine of alpha plus beta and do sine of 90 minus alpha plus beta. Now, this should already look familiar. This looks more similar to the identities we already have, and we can simplify this even further to sine of 90 minus alpha minus beta, just distributing into the brackets. And now we can use this and break it up into a different arrangement to make it manageable to plug in to the identities we already know. And we're going to do this by doing the sine of 90 minus alpha. We're going to group 90 minus alpha and subtract beta. And now, if we were to say 90 minus alpha was actually equal to the alpha in our sine of alpha minus beta, this would suddenly be very easily solved with our trigonometric identity for sine of alpha minus beta. So let's go ahead and solve it using that. So the sine of 90 minus alpha minus beta is equal to the sine, and here we're going to plug in our 90 minus alpha in place of our regular alpha. So 90 minus alpha cosine beta minus the sine of beta cosine 90 minus alpha. And once again, how do we simplify this? And well, we're going to come right back to these two identities up here. We know that the sine of 90 minus alpha is equal to the cosine of alpha. So what we get is the cosine of alpha cosine beta minus the sine of beta. And once again, we know that the cosine of 90 minus alpha will be equal to the sine of alpha. So we get sine of beta multiplied by sine of alpha. Since the sine of 90 minus alpha minus beta is equal to the cosine of alpha plus beta, it then follows that the cosine of alpha plus beta is equal to the cosine of alpha times the cosine of beta minus the sine of beta times the sine of alpha. So I'll put this up again in our set of identities up here. Cosine alpha cosine beta minus sine beta sine alpha. And for the last and final identity, I'm going to go ahead and erase everything to make some space. Make it a little bigger. For the final identity, we're going to take the identity we just found, and we're going to do the same thing we did with our sine conversions, where we simply use the negative beta in place of beta. So we're going to get cosine of alpha minus beta is equal to the cosine of alpha plus negative beta, which means that the cosine of alpha plus negative beta is equal to, using the identity we just found, the cosine of alpha times the cosine of negative beta minus the sine of negative beta times the sine of alpha. That should be an N and M. Now, using basic trigonometric identities, we're going to convert the negative betas in the cosines and the sines into what their forms would be if we were using a positive beta. So cosine of alpha, cosine of negative beta is simply equal to cosine of beta. So that turns into cosine of beta. And now we move to the other side where we get minus sine of negative beta. Now, sine of negative beta is equal to negative sine of beta. So the negatives cancel out, make a positive, and we get plus sine of beta times sine of alpha. And that's the final thing. And now that we have our equation for cosine of alpha minus beta, I'll write it back at the top, and now you can see all of our equations for each sum and difference of angles trigonometric identity written up top. So we get cosine of alpha cosine beta plus sine alpha sine beta. And those are your 4 sum and difference of angles trigonometric identities.